Hello everyone, welcome back to my channel. So today let's discuss this problem, minimum size subarray in infinite array. So I have attached the problem link and the solution link in the description. You can check out. In this, first we will understand the question, and then we will try to build the logic by covering all the corner scenarios, and we will see the code in the high level. So first let's understand the problem statement. Here you are given a zero indexed array numbers and an integer target. A zero indexed array infinite numbers is generated by infinitely appending the elements of numbers to itself. Is saying that suppose I have elements x1, x2 and x3, and I can append same elements x1, x2, x3. I can append till x2, x3 infinitely. I can append it. Now we need to return the length of the shortest subarray of array infinite numbers with an equal sum equals to target. We suppose if x3 and x1 sum is equals to target, then we need to return true, and if x2 is equals to that sum, then we need to return 1 because we need the shortest subarray. If you see about shortest subarray, first thing will come into your mind is sliding window. So I will explain you sliding window technique in the end, and I think most of you know what it does. It will take two pointers I and j, and then we will iterate till we find the target, and then we will decrement i's parallelly. So we will see that in the code. First let's understand the logic. Let's see the scenarios. He's saying that constants are 10 power 5. We should do in order of n or order of n into log n, not more than that. So let's see. In the case 1, let's say target is equals to 7, and this my target is less than is sum of all elements. If you see here, target is 7, and if you add all these elements, it is 7. So my answer is 4 here. But if I append this element, if I append this numbers, then you can see here my answer is 2. So I got the answer as 2, which is my shortest. Now if you see the case 2, if my target is less, then I will append it and I will check whether minimum I am getting minimum or not. So we need to prove 2 arrays are required. Now we need to prove that 2 arrays are required. So we need to see if we append 3. He is saying infinite subarrays, but if you see that target is less than sum, then can we generate appending by 3 arrays? Let's see. Suppose my target is 13. If you see here, can you find 13 here? 6, 2 plus 2, 8, 4, 8 and 16. 16 is greater than 13, so I will decrease this. And in the same way, now I will get 12. Now here I am getting 14 is greater, I will decrease. And if I go here, still I am getting 14, so I will decrease. Now here I will be 10. Now still I will be 14 if I decrease this, and coming to this my array will be 14. So my 13 is can't reachable. If you see, if you compute in these two arrays, if I append this, and we will perform the same operations on this. If it is failing for this, then definitely it gonna fail for all this subarrays. If you append 3, also it's gonna fail. If you append 4, it's gonna fail. If it is fail for 2, then it will fail for everything. Now let's see. In the third scenario is now target percentile sum is 0. Suppose my target is 14 or 28 or 42. Now if you add this is 14. If it is 14, my answer will be 1. If it is 28, 14 means my answer will be 4, because all the subarrays should be included. If it is 28, 4 into 2. If it is 42, it is 4 into 3. I think you have got it. If target percentile sum is 0, then you can directly do that. If my target is greater than sum, suppose my target is 29. First we will calculate the remaining. Remaining means we will calculate the case 3 elements. Target divided by sum into n, because here my sum is 14. If I include all elements, I am getting 14, and if I include these elements, still I am getting 14. So can I deduct 28 from this? Definitely I can deduct 28 from this. if I deduct 28, my target will be 1. Target will be 1. So what I am saying is that 28 means there are 2 subarrays which I will include, and my target is 1. Directly we will get the target. So this condition is satisfied. Suppose let's see if the target is 30. Target is 30. Okay, this is my subarray which I am considering, this subarray which I am considering from this 28. Now 2. Okay, 2 is here. Can we append this? Now 1 is here. So we thought 1 is here. Okay, but 2 is here. Can we do that? Let's see. Now let's build this array. Let's just build array. Let's consider this 2 from the beginning. This 2 from the beginning. If you see this, we have considered 2 here, and we have included this 236, and this will be my same. This will be my same, and here I will include only 1 and 2. In this way, if you see, all these elements are repeated. 2 got twice. If you see here, this 2 to this 2 I got twice, and the remaining all elements are repeated. So whenever if you get the subarray in the remaining elements, if you find the subarray sum which is equals to my remaining target, then definitely you can get an answer. Now let's see. Now you can code yourself by saying 4 scenarios. You can code yourself. If you're unable to code, I can show you the code. Now sum is greater than 0. We are taking the sum. This is my case 1. This is my case 2. Sorry, this is my case 3. I'm really sorry for that. Target percentile sum is equals to 0. If it is k percentile is, k is my target, k divided by s into total number of elements, which we have done over here. K 4 into 2, 4 into 3. And now this is my case 4, which I am considering case 4 to get the remaining target. So remaining is equals to k divided by s into n. Here we will get 28. We got, if my answer is 29, if my target is 29, we will get 28 from this. 28, and 29 minus 28, my k will be 1. My remaining target will be 1. So in sliding window, I will check for only 1, and this remaining answer I will add to this answer, because this is all subarrays which are appended, complete subarrays. Now let's see the sliding window. I is equals to 0, j is equals to 0, and answer we are taking as int max. If the answer we couldn't found, then we will return -1 as described in the question. Now I less than j and j is less than k. We are incrementing s is equals to s plus v of j, and if s is greater than k, now suppose my I is here and j is here, till I to j, if I add all these elements are greater than k, then we need to definitely increase I by subtracting from this. Yes, my I will come here. In the same way, if I got 0, 0, 0, and I am at 5, but my target is also at 5. If you see 0, 0, 0, 5, my total length will be 4. And if s is equals to k, I can decrease. This is 0, then definitely I can decrease to get the minimum size. Yes, I can come here, then I can decrease. In this way, if s is equals to k, we are decrementing and we are subtracting the answer, and eventually we are incrementing the j. And if answer equals to into max, we are returning -1, and we are adding the remaining answer to our answer. So I think you understood this solution. You can think about time complex. What would be my time complexity? It would be order of n plus n. So this we can say as order of n. My space would be order of n, because I have appended. You can see here I have appended the vector into v, so it will be order of n. The space will increase. I think you understood this. If you understand the solution, please do like and subscribe to my channel. I will post all the solutions related after the contest in my channel, and thank you for watching.